All right, good night, everybody. What I want you to think about is what we learned from being in the lab counting those teeny tiny little beads the other day. Wouldn't it be nice if there was an easier way to count those little beads? And didn't you figure that out when you realized that you could just pour those 200 beads onto the balance if you weighed them by using grams? It was just really so much easier to weigh out 1.9 grams of beads knowing that there were 200 in there. Well, that's what today's lesson is all about. We're going to learn that instead of attempting to count itty bitty atoms, which we really can't do anyways, we're going to use a unit called the mole. On this slide, we're going to talk about 3 vocabulary terms. You've already built your vocab cards, but I want to make sure we explain these 3 terms to you. The mole, by definition, is the quantity of any chemical that has the same number of particles as 12 grams of carbon-12. When we talk about quantity here, we're talking about particles. When we're talking about particles, we're talking about atoms or molecules. They don't all have to be single atoms. These can be molecules, compounds. We're talking particles, individual units. Avogadro's number has been defined as 6.022 times 10 to the 23rd atoms that are found in 12 grams of carbon-12. We like this number. Test after test after test indicates to us that this is how many atoms of carbon-12 are in 12 grams of carbon. And we designated that number, Avogadro's number, to be 1 mole. We can further take these 2 definitions of the mole and Avogadro's number, and we can define something called molar mass. Molar mass is the mass in grams of 1 mole of any substance. So all of those AMUs on the periodic table that we learned how to calculate when we learned how to calculate the weighted average atomic mass in first semester, we now can drop that AMU and we can add a G. So this allows us to use the average atomic mass off the periodic table for the grams, and any mass off the periodic table is equal to 1 mole of that substance. And when we talk about 1 mole of that substance, then we're talking about the mass of 6.022 times 10 to the 23rd atoms of that substance. Just to show you exactly how big this number is and exactly how many atoms there are involved, or particles, for 1 mole, the population of the world is estimated to be about 6 billion people. 1 mole of any substance contains 602 sextillion, 200 quintillion particles. OMG, people, that's a lot of particles. Before we can use calculations with the mole, we need to learn how to calculate molar mass. You're going to need your gold sheet with your periodic table on it in order to do this. We need to calculate the molar mass of calcium nitrate. In order to do this, we need to look up the masses of calcium, nitrogen, and oxygen. But before we do that, we further have to figure out how many atoms of each element are in the compound calcium nitrate. That's the easy part. We learned how to do that a few units ago. When we look at the formula, we see that we have 1 calcium. So 1 calcium. 1 calcium. And when we distribute the 2 into the parentheses, we have 2 nitrogens and 6 oxygens. Now looking up the masses on the periodic table, we see that the mass of 1 calcium is 40.08 grams per mole. 2 nitrogens, we take 2 times the mass off the periodic table, 14.01, and we get 28.02 grams per mole. For oxygen, oxygen's mass is 15.9995, so we just round that to 16. So we'll take 6 times 16, which gets us 96 grams. When we add all of these up together, we get 164.1 grams per mole. Another way to say this is that there are 164.1 grams of calcium nitrate equal to 1 mole. This slide I'm not really going to talk about too much. This is a mole map. We're going to use this in the next 2 slides for our examples. I need you to stop this video and copy this down in its entirety. I also want you to make sure you copy down what STP stands for. In the last slide, I asked you to copy down the mole map. I have another picture of it here at the bottom right-hand corner for our use in this example. If you did not copy this down, please copy it down now. For our first example, we're going to look at how we calculate the number of moles that are in 8.32 times 10 to the 26 atoms of iron. Atoms here tells us that we are going to be looking for a way to get to particles. Please stop the video and copy down this example. Alright, let's see how we go about using the mole map and dimensional analysis in order to figure out how many atoms of iron are in 8.32 times 10 to the 26 atoms. We need to have a strategy. So let's pick out a strategy. Okay, our strategy here is to go from atoms of iron to moles of iron. And when we take a look here, to go from moles to particles, we need to use Avogadro's number, 6.022 times 10 to the 23rd. So let's use that as a dimensional analysis setup here. Alright. So we now need to create our equality. We call that our known. And we know that there are 6.022 times 10 to the 23rd atoms of iron in 1 mole of iron. The last thing we do is calculate. We're going to use dimensional analysis. We haven't used this since chapter 1. You will have to look it up if you're not sure where I'm getting everything from. But if you recall from chapter 1, whenever we run a dimensional analysis problem, we always write our given value first, including the units. So we have 8.32 times 10 to the 26th atoms of iron. Then we build our conversion factor. Oops, I don't want that guy. No. Alright, hopefully I don't run into this guy. So then we build our conversion factor. We want to get rid of atoms, and whatever we want to get rid of goes on the bottom. So we're going to put atoms on the bottom of iron. And we want to get 2 moles of iron. So when we look here, again, we're going to go from moles to particles using 6.022 times 10 to the 23rd. So there are 6.022 times 10 to the 23rd atoms of iron in 1 mole of iron. When we do this math, and we put it in the calculator, remember to use your EXP button or your EE button on a TI, we get a calculator answer of 1,381.6 moles but because of sig figs, we started with 3 sig figs over here. We can only keep 3 sig figs. Our final answer is 1,380 moles of iron, and that is our final answer. Before we start example 2, please stop the video and copy down the problem. Okay, this problem is a little bit different than the first problem. This problem asks us to calculate the mass in grams of 14.32 moles of sodium chloride. In order to do this, we need to look at our mole map, and we're going to be going from moles to mass. The row tells us that we have to use molar mass using the periodic table. So let's take a look at how we do that. If we need molar mass, that means that we need to add up all of the atoms' average atomic masses off the periodic table, which means we need the formula for sodium chloride. It's a good thing that we know how to write formulas, because we know that sodium chloride is NaCl. So we need a strategy. Our strategy this time is to go from moles of sodium chloride to grams of sodium chloride. I'm going to have you work out the strategy, the known, and the calculation for all of your problems at the beginning here, just until you get used to what you're doing. So make sure you copy all of this down. Alright, now our knowns. We need to know the molar mass, okay? So when we look up 1 sodium, we see a mass of 22.99. Oh, let me put the A in for sodium. Hang on one second, let me erase this. So 1 sodium atom is roughly 23 grams, and 1 chlorine atom is 35.45, for a total of 58.45 grams of sodium chloride is equal to 1 mole of sodium chloride. That is molar mass. 58.45 grams is the mass of sodium chloride in 1 mole of sodium chloride formula units. Alright, let's get to the calculation. We always start with what we're given, so we're going to start with 14.32 moles of sodium chloride. We want to get rid of moles, so we're going to put moles at the bottom. And notice I'm putting the unit and the chemical. We have to do that in order to be counted correctly. I will mark you wrong if you don't do this. We want to get to grams of sodium chloride, and our numbers follow. The grams is 58.45 to 1 mole. When we do that math, we get a calculator answer of 837, let me write this down, 837.004. But we know our sig figs, and since we started out with 4, we can only keep 4. So our final answer is 837.0 grams of NaCl. And that, ladies and gentlemen, is our final answer. We'll continue to discuss the concept of the mole and the mole calculations tomorrow in class. I hope you have all of these notes. Make sure you copy down all of the problems. Have a nice night. See you tomorrow.